We fear the silence of space, the horrifying thought of drifting through a soundless frozen vacuum. But what if the silence isn't real? What if it's just a filter, keeping us from going mad? Silence is an illusion, a protective barrier built by our biology. The reality is far more unsettling. The universe is screaming. From the hidden cults of ancient Greece to the laboratories of NASA, the greatest minds in history have stumbled upon the same truth. The cosmos isn't a place, it's a frequency. A resonance that modern masters like Hans Zimmer are only just beginning to decode. Over 2,500 years ago, a man named Pythagoras claimed to hear something no one else could. He called it the Musica Universalis. He argued that the stars and the planets aren't just drifting in the dark. They are constantly screaming through the void in a perfect mathematical harmony. A cosmic roar that we are simply too small to hear. We don't live in a world of matter. We live in a world of vibration. And someone or something is conducting. Welcome to Musica Universalis. Imagine being an isolated observer in the middle of a symphony orchestra. To you, the room is quiet. The frantic movements of the violinists and the heavy strikes of the percussion are just visual data. But the air is actually screaming with energy. We are that observer, lost in a masterpiece we cannot hear. To understand the true scale of a singing universe, we must look through the eyes of the man who first heard it, Pythagoras of Samos. Most of us remember him only as the triangle guy from math class. But to those who knew him, Pythagoras was a dangerous mystic who believed that numbers weren't just tools, but literal gods. According to legend, his journey into the cosmic soundscape began at a simple blacksmith's forge. As the hammers slammed against the anvils, he noticed something impossible. The different pitches weren't random. He realized that the harmony of the strike was determined by precise mathematical ratios. This discovery led him to a radical conclusion. If music was math, and the stars followed math, then the stars must be making music. He called it the Musica Universalis, the music of the spheres. In his eyes, the orbits of the moon, the sun, and the stars produce a constant, colossal roar of harmony. But if the universe is screaming, why do we hear nothing? Pythagoras argued that we are all like people born inside a waterfall. We've heard the roar for so long that we can no longer distinguish it from silence. He envisioned the cosmos as a massive, rotating orchestra playing a composition so vast that the human ear simply cannot filter it. In his theory, every celestial body produces a note through its movement with the ether. The more massive the planet, the deeper the growl. The faster the orbit, the sharper the scream. To his inner circle, this music wasn't just art. It was the mathematical blueprint of existence. They feared that if the common man truly understood that the universe was governed by fixed musical ratios, it would shatter our very perception of free will. We wouldn't be masters of our fate, but merely notes in a song we didn't write. If the orbit of Jupiter is just a note in a celestial composition, then your life, your history, and your death might just be vibrations in a pre-written score. Humanity has always seen itself as the center of the stage. But Pythagoras suggested a much more humbling truth. That we are merely listeners in a concert that began billions of years ago. Yet, what does it mean for the listener if the music is already written? If your life is just a preset vibration in a cosmic arrangement, do you even own your own soul? Or are you just a character in someone else's song? To find the answer, we have to look at the man who actually tried to write the notes down and went mad doing it. For 2,000 years, This vision remained nothing more than an unsettling dream, until Johannes Kepler decided to turn that dream into math. Kepler was a man caught between two worlds, a brilliant mathematician by day and a mystic searching for the mind of God by night. He was obsessed with transcribing the song of the planets. He believed that if he could transcribe the symphony, he could prove the universe was a perfect divine masterpiece. But what he found broke him. Kepler discovered that planets don't move in perfect holy circles. They move in ellipses. This means their speed changes. They speed up as they approach the sun and slow down as they pull away. In musical terms, their pitch shifts. He painstakingly wrote out the musical notation for each planet. Saturn was a deep guttural bass. Mercury was a frantic, chaotic trill. But when he reached Earth, he found something that filled him with cosmic dread. Earth's velocity changes just enough to create a specific interval, a semitone. In the musical language of the 17th century, the semitone, the half step, was the interval of the lamento. It was the sound used to express weeping, sorrow, and pain. Kepler wrote that Earth sings mi, fa, mi, standing for miseria and fames, misery and famine. Think about that. The man who dedicated his life to proving cosmic perfection found that our planet is literally encoded with the frequency of suffering. Kepler wasn't just observing physics. He felt he had stumbled upon a cosmic confession. Was he just chasing echoes in the void? Or had he finally tuned into a frequency that was physically there? If we are part of a grand symphony, Kepler's data suggests that Earth's role is the tragic solo, a perpetual moan in the middle of a celestial masterpiece. For centuries, we called him a mystic. But then, modern science discovered something about the nature of matter that made Kepler's miseria sound less like a metaphor and more like a revelation. What if the stuff you touch isn't solid at all? Kepler's madness was simply a truth born too early. It would take 300 years and a man named Nikola Tesla to prove that the universe isn't made of stuff. It's made of signals. He cared about the invisible threads that hold matter together. He famously said, "If you want to find the secrets of the universe, think in terms of energy, frequency, and vibration." Tesla understood what Pythagoras and Kepler were trying to say. He realized that our brains are just receivers, tuned to a very narrow band of frequencies. We think space is silent because we are deaf to the static of the universe. He realized that the universe is an ocean of energy. But to truly replace the illusion of matter with the reality of vibration, we needed a stronger foundation. We needed Albert Einstein. Einstein's genius was in seeing what was hidden in plain sight. His iconic equation, E equals mc², isn't just about atomic bombs. It's a philosophical revelation. It proves that mass and energy are interchangeable. They are just two forms of the same thing. Think about that. The coffee cup in your hand, the screen that you are staring at, it isn't solid matter. It is trapped, crystallized energy. Matter is just energy that has slowed down enough to be perceived by our limited senses. But how does energy slow down into matter? This is where modern physicists like Michio Kaku and Brian Greene expanded Einstein's vision, leading us into the bizarre world of string theory. String theory proposes a concept that sounds like it was pulled straight from Pythagoras' secret diaries. It suggests that if you look deep enough into the heart of an atom, you won't find tiny billiard balls particles. You will find a vibration. The fundamental building blocks of reality are tiny, rhythmic loops of energy, strings. And just like the strings on a violin, they play different notes depending on how they vibrate. One frequency creates an electron, Another creates a quark, the tiny vibrating core inside every atom. Think about the terrifying implication of this. The entire physical world, your body, the stars, your very thoughts, is literally nothing more than a localized harmony of strings. We aren't stuff in the silent universe. We are a standing wave. We are a symphony that has taken a physical form. Michio Kaku once summarized this beautifully. The mind of God is cosmic music resonating through 11-dimensional hyperspace. If we look at the universe through the lens of string theory, it begins to look less like a place and more like a mathematical program, a simulation, perhaps written in the language of music. And in this grand design, we might just be the feedback, the unintended resonance produced by the friction of the cosmic signal. But if we are the music, then who is the audience? And more importantly, if the universe is a roaring ocean of frequency, why does it feel so cold and empty when we look up? What if the silence we've been studying for decades isn't a void, but a mask for something much, much louder? We used to think that the cosmic silence is just a sign of a dead universe, but the reality might be far more overwhelming. Maybe the universe is a roaring engine, a 13.8 billion year-long scream of energy. We haven't found others because we've been trying to hear a whisper inside a hurricane. We weren't alone. We were just tuned to the wrong frequency. For decades we thought black holes were the ultimate silent assassins. Regions of space where nothing, not even sound or light, could escape. But Stephen Hawking proved us wrong. Hawking discovered that black holes are not perfectly black. They leak. They release a tiny amount of thermal radiation, now known as Hawking radiation. This evaporation means they are not static, they are active, and they scream. And recently, NASA showed us what it sounds like. In the Perseus galaxy cluster, astronomers sonified the data from a massive black hole. That doesn't sound like harmony or structure. It sounds like a ghost caught in a primordial storm, like a cosmic throat trying to swallow the light itself. It is immense, inaccessible, and in many places violently loud. We are like microbes drifting across the mahogany lid of a grand piano, while a master plays a chaotic concerto. We feel the vibrations under our feet. We see the hammers falling, but we can never ever comprehend the melody. The true dread isn't the fear of being alone in the void. It's the realization that we, and whoever else might be out there, are part of a composition we don't understand, written in a language we can't speak. We are drifting through the movements of a cosmic symphony, with no idea when the final bar is scheduled to begin. But if this cosmic roar is so indifferent to us, why do we feel it so deeply? Why does a simple melody have the power to make us weep, as if we are remembering a home that we never visited? To understand that, we have to look at the man who understands to mimic the sound of the universe itself. Before we reach to the final note, if you could hear the frequency of your own life right now, would it be a harmony or a dissonance? Let me know in the comments. If the universe is such a terrifying performance, why does music have such a profound, almost spiritual effect on us? Why do we feel a vibe when there is no air to carry it? This is where the emotional architecture of the cosmos meets our human soul. We are designed to respond to these frequencies because we are these frequencies. Consider the work of modern film composers like Hans Zimmer. Zimmer doesn't just write melodies. He crafts sonic environments. He uses sub-bass, drones, and mathematical repetition to make us feel the cosmic vibe. When you hear the pounding rhythmic drive of Interstellar, you aren't just listening to instruments, but to an interpretation of the temporal distortion of a black hole. You are feeling the gravity of a distant, massive object. Zimmer's music resonates because it taps into the fundamental hiss of the mechanism driving our reality. the cosmic microwave background, the afterglow of the Big Bang. When scientists took the data from that 13.8 billion year old light and scaled those frequencies up so we could hear them, it was a roar, a deep primordial growl that laid the foundation for everything. Maybe Pythagoras was right. Maybe the music never stopped. If we accept that the universe is a symphony of order hidden inside the mask of chaos, where every vibration follows a law and every frequency has a place, we have to ask, what happens when the music changes? In music theory, there's a concept called the resolution. It is the moment when a tense, discordant chord finally finds its way back to the stable, peaceful home, the tonic. For 13.8 billion years, the universe has been expanding, vibrating, and shifting. It is a composition still being written in real time. But every song has a final note. Cosmologists talk about the big freeze or the heat death of the universe. A time, trillions of years from now, when the last star flickers out and the last black hole evaporates. In the language of Musica Universalis, this isn't just a physical event. It is the final bar of the score. The moment the vibration stops and the universe finally fades into absolute silence. But until that day, we are participants in the greatest performance imaginable. We are not just observers looking at the distant, silent sky. We are the instrument on which that universe plays. Our bodies are made of the same vibrating strings as the stars. Our hearts beat in a rhythm that echoes the cosmic pulse of ancient planets. The next time you stand under a clear night sky, don't just look for the light. Close your eyes. Feel the vibration in the ground beneath your feet, because the universe is not silent, it's screaming, it's singing, and it's beautiful. And remember, silence is just a sound you haven't learned to decode yet.